So remember that an AI agent is powered by a large language model. So we are talking about a proper brain, right? Now, this brain is able to orchestrate all these tools, all these capabilities that we provide our agent with, thanks to its intelligence and the autonomy we provide the agent with. So let's say that autonomy, tools, and system message or job description are probably the main ingredients that compose an AI agent. And the reason why it matters is because AI agents are redefining the way we work from a productivity perspective, the way we automate processing from an RPA perspective, and the way we develop applications from a customer experience perspective.
Welcome to ODSC's AIX podcast, your gateway to the latest in AI and data science. This episode is sponsored by ODSC East, the premier AI Builders Conference, celebrating its 10th year this May 13th to 15th in Boston. Learn more at odsc.com/Boston and use the code ODSC Podcast for an exclusive 10% discount. Seamus McGovern, the founder of ODSC, will be your host today.
Hi, everyone, and welcome to another episode of the ODSC podcast. Today, we're exploring one of the most interesting trends in AI right now, AI agents and agentic workflows. Joining me for this conversation is Valentina Alto, a technical architect specializing in AI and apps at Microsoft. Valentina brings extensive expertise in generative AI, large language models, and multi-agent systems. She'll help us unpack how we're moving from traditional AI assistants towards more powerful, intelligent automation with AI agents. We'll dive into what exactly makes an AI agent, why major enterprises are betting on this technology, and discuss practical ways to navigate both the challenges and opportunities ahead. So let's jump in. Valentina, welcome to our live stream and podcast.
Hello, and thanks for having me today. I'm super excited.
Yeah, so Valentina, a lot of people are saying 2025 is the year of AI agents and agentic AI. You've already given a number of great talks and workshops at ODSC and other conferences around agentic AI. So you, and especially with your role at Microsoft, you've been ahead of the curve on all that, I would say. I was just doing some research last week, looking at some industry reports from large consultant agencies. I noticed that Gartner listed agentic AI as their number one technology trend for 2025. And I was looking at McKinsey reports, and they're saying that most enterprises plan to adopt agentic AI across various operations from customer service to manufacturing. And it was very similar reports from Boston Consulting Group, Deloitte, Capgemini. They all echoed similar sentiments. So why are all these major enterprises focusing on agentic AI, and what's driving their interest in this technology?
Many things, I would say, but to start with, we need to understand what is an AI agent and why it matters in the landscape of generative AI, but more broadly speaking, in the landscape of technology, and how we are redefining not only automation, but also applications and customer experiences. If we think about AI agents, we need to think about these kind of AI-powered entities that are provided with a clear mission or job description. It's basically the natural language description that you provide the agent with in order to accomplish a specific goal. And this hyper specialization is one ingredient that differentiates AI agents from traditional generative AI, which is generative. Then AI agents are also provided with knowledge, which is specific, domain specific to what we want our agent to operate within, like the domain that we want our agent to be specialized in. And then I would say most importantly, AI agents are provided with skills or tools. Skills are capabilities that we provide the agents with to perform things around the surrounding ecosystem. When I say surrounding ecosystem, I refer to technological platforms that surround the entity that we build as an AI agent. Those might be, for example, system of records, might be existing processes, might be applications. And the way these tools are orchestrated by the AI agent, it's probably core, the beauty of this new technology and why everyone is talking about that. So remember that an AI agent is powered by a large language model. So we are talking about a proper brain, right? Now, this brain is able to orchestrate all these tools, all these capabilities that we provide our agent with, thanks to its intelligence and the autonomy we provide. So let's say that autonomy, tools, and system message or job description are probably the main ingredients that compose an AI agent. And the reason why it matters is because AI agents are redefining the way we work from a productivity perspective, the way we automate processing from an RPA perspective and the way we develop applications from a customer experience perspective.
Yeah, Valentina, you've done a number of talks and workshops for us at ODSC, and we just had a AI Builder Summit about a month ago, which you gave a great session there as well. Would love if you could give us a little bit more about your background, your role there at Microsoft, and the books you've written, and maybe a few key moments in your career, if you don't mind.
Yeah, of course. Why not? I joined Microsoft 4 years ago, actually 5, now that I think about that, in Microsoft Italy. My background is I'm a data scientist. So I loved, by the way, the introduction talking about how machine learning is still important in that lesson. I 100% agree. Around data science, joined Microsoft as a solution specialist in Azure, focusing on cloud architectures. I was a cloud specialist and then transitioned towards the data and AI domain. So I was focusing mainly on machine learning, AI. And then November 2020, and Azure OpenAI conversation started. I was fortunate enough to be a sales specialist in AI back then. I had the opportunity of working on amazing projects with customers in Italy in the first year of generative AI, starting from standard retrieval augmented generation projects and then moving towards more complex pipelines, including agentic AI. And then 8-9 months ago, I relocated to Dubai as a technical architect in AI and app innovation. I decided to transition towards the app landscape because when we talk about AI applications, we need to know about applications, right? So I was feeling like the conversation from pure AI was shifting towards how do we develop around large language models? How do we build the business logic around large language models? That, by the way, is what working with AI agents is about. And probably we will touch base on that later on in the podcast, but building AI agents has reshaped the way we develop applications.
You mentioned some very important components of agentic AI and AI systems. You had that large language model, which you mentioned is the brain, and we have autonomy, tools, and skills are the main ingredients. But I think it's good to set context here because one of the questions I have, how are AI agents and agentic workflows different from AI assistants? And I think some people get confused about what is an AI assistant. And to me, AI assistants really came about when I got my first Amazon Alexa and then Apple HomePod. But it was like an AI assistant or a voice assistant. And then, of course, I still count Claude and ChatGPT as AI assistants, right? And that was late 2023. We could type questions in. To this day, we can get wonderful answers and next token prediction out of these AI assistants. How would you define AI assistants and how this new wave of agentic AI is different from an AI assistant? If you can dive into that question a little bit.
Yes, of course. You made the example of Alexa, right? So think about that. Would Alexa be able to add to your cart an item if you want to buy something on Amazon? I don't think so. Or would Alexa be that hyper specialized to provide you with exact information, which is part of a very specific domain, maybe not available on the web, which you might want to infuse in the job description that you provide your AI agent with? So these two elements, I would say, hyper personalization and toolkits to perform actions are probably the main differentiator between an AI agent and an AI assistant. And again, very important, the autonomy. Autonomy is the ingredient needed in order to operate with the tools that the agent is provided with. So the autonomy is the capability of the AI agent of orchestrating tools and actions, performing actions in an autonomous way, deciding when to do what. That's the autonomy that differentiates an AI agent from an assistant. So conversational back and forth experience, AI assistant, versus autonomous and actionable experience, AI agents.
Exactly. So let's talk a little bit about the major advancements, technological or otherwise, that have facilitated this transition. Because you mentioned the most important one, which is, of course, the large language models. They act as that brain. And that's been a big deal. If you can walk us through that, because when ChatGPT 2.5 came out, we're in a very different place now with 4.5, which is just released a few weeks ago. Now, all these reasoning models. So you can talk a bit more about what are the other major advancements that's made this
Yeah,
possible.
sure. So if we try to accelerate the last 2 years and a half in minutes, let's say that we started with large language model, for example, ChatGPT. ChatGPT is an application around a large language model, but at the end of the day, it's an API call. So we're not adding any application logic around that. The first problem that we faced with applications similar to ChatGPT was that large language models are limited in their knowledge. They don't know about up-to-date information, and luckily, they don't know about our private information. The first milestone that we achieved was infusing knowledge base, external knowledge base to these models. And this approach is called retrieval augmented generation, allowing the model to navigate and surface an external knowledge base so that the context that we provide the model with is relevant for us. That was the very first milestone, I would say. The second one is probably the multimodality. So when we talk about large language models, as the name suggests, we refer to text, right? Text input to text output. However, the architecture of this model can actually handle diverse data. And the beauty of large multimodal models, meaning models that are able to input and output different format of data, is that these models keep the same reasoning capabilities of large language models, yet applied to a broader variety of data. Meaning that I can reason over images, asking questions in natural language and receiving as an output an image, for example. So large multimodal models actually mimic the way our brain works, perceiving things around in different format, different input in different format. And then we started moving towards the agentic conversation, meaning adding actionable capabilities to these models was probably the third milestone we achieved. Not only generating content, but also executing functions or performing operations in the surrounding ecosystem was something that we started providing our LLMs with. The first glimpse of agentic AI, even if it was not by definition an AI agent, was the function calling capability introduced by OpenAI, the capability of an LLM of invoking different functions. With the AI agent, we are, let's say, adding an extra layer of intelligence since we are providing a clear mission or system message to the agent. We are hyper specialized. In parallel, we are advancing from a research perspective. For example, we now have small language models, a new category of models that are more manageable, can be deployed offline or on-prem more easily, and can be fine-tuned more easily. Fine-tuning means training the model to hyper-specialize it, but not in its entirety, just in a subset of parameters, meaning that you are not spending a lot of money and time, but rather just tuning the way the model performs. Small language models are very manageable from this perspective. This goes hand in hand with the AI agents conversation because you might have multiple AI agents for multiple purposes, meeting multiple models. I'll give you an example. If you have an AI agent which is particularly specialized in understanding and generating code, you might want to leverage a specific large language model or a small language model for that. But at the same time, this agent could cooperate with another agent which needs another model, maybe a reasoning model like the O1 or DeepSeek, because the kind of task, the kind of job description that it is provided with requires that kind of LLM capability. So the modularity of AI agents is also this, the possibility of plug and play with different components and having full flexibility in the way you initialize these components within an agent.
Valentina, so much to unpack there. You touched upon so many of my favorite topics. The multimodality is absolutely fascinating. I've seen a number of talks at ODSC, especially around e-commerce and enterprise, using these multimodal LLMs as well as agents to improve recommendation systems and helping people shop. Like you're on a shopping e-commerce site. And small language models and fine-tuning. As you mentioned, lots of small language models to do lots of specific tasks. I definitely want to get to multi-agentic systems, which I think we'll get to later in the conversation. And I know folks are posting a number of questions, but don't worry, I see them. I was just looking at some great questions in there to keep the conversation going. I will include those questions when we get to that topic. One of the last things, because you mentioned again, you must be doing some fascinating work because you're on the nose when it comes to all these topics. You mentioned the different agents for different models, which I know is a really hard one because we've been looking at some startups that do this idea of a large language model broker, right? Because we know picking the right model for the task is hard and there's multiple tasks involved. So this concept of an LLM broker, can you send it to one large language model versus the other one, depending on your criteria? It could be cost, it could be latency. When OpenAI came out with their reasoning models in that blog post. They talked about this planner and worker, I would call it a design pattern. Maybe you have a planner that might be a reasoning model, calling a cheaper model, it's a worker model. Some great stuff there. And I think there are lots of interesting use cases here. Let's touch upon some of the questions. One thing everyone is concerned about when I talk to executives coming to ODSCs, I ask them, what's your number one issue with large language models and deploying them in production? The word I keep hearing is trust. When you go to AI agents, you mentioned autonomy a number of times. It's one thing to not trust the output of a large language model, but how do we balance between an agent's autonomy and its alignment with users' intentions?
No, of course. So it's, first of all, trust. I feel like it will always be a topic in AI. We will probably never get to the point where we could trust 100% fully autonomous system. Or maybe yes, I don't know. But I have the feeling that we will always need to be involved and concerned when it comes to these solutions or applications. But back to your question, so autonomy. Let me be more specific about autonomy. Autonomy can have different flavors, the range. The beauty of autonomy within an AI agent is that we can define the degree of freedom we want to provide our agent. I'll give you an example. There might be scenarios where you want to hard code the sequence of agents and maybe even the sequence of the tools invoked by the agents in a predefined and scripted fashion. In that case, we might have a sequential workflow. And when I say workflow, I refer to the pattern design of cooperation across different agents. Or you might have a hierarchical workflow where you have different level of abstractions, starting from supervisor that we orchestrate different agents doing different things. You mentioned the operator from OpenAI, right? So that is an example of hierarchical multi-agent application. At the lower level, you will have atomic agents doing one thing, which is an API operation against a website. Then you will have some agent that will record the screen to understand what's happening. You will have a planner, and then you will have a supervisor. So this is a great level of autonomy, right? But again, it's up to you and how you define the degree of freedom that you want to provide your agent with. I give another example. In the academic field, there are some scenarios of multi-agency where you have a group chat workflow, meaning that you literally leave your agents doing their stuff, talking to each other, for example, generating new ideas. So in that case, it's not a production application or a customer-facing application. It's a team of assistants that are super creative and might come up with new ideas you've never explored. Depending on the use case, you might want to enforce degrees of freedom and autonomy. This doesn't exclude the issue of trust, because even with the most coded process, we still need to have a human in the loop to approve, to validate, right? For sure at the beginning. Then we might want to delegate a bit more to the AI agents or a bit less, depending on the output that we are having in the first period of adoption. That's why it's so important, especially for large enterprises, to be equipped with, let's say, blueprints that allows them, technically speaking, to deploy and fail fast. Because there are scenarios that you have to try. There is no golden recipe, especially in the field of AI agents, to define the perfect balance between autonomy and hard coding, which is the perfect number of skills or tools that you want to provide your agent with. So I'll give you an example. A question that I'm often asked is, which is the perfect number of actions that an agent should have? The thing is, we need to try, because actions have different level of complexities. So it's about testing, trying, and failing fast in case it is not working out, if it makes sense.
Yeah, it makes a ton of sense, because one of the things we struggled with was when you have these multiple agents chained together in a workflow, there's a phenomenon where small error rates for each individual agent can compound dramatically. I guess we call it error propagation or error compounding, would be a better way to say it. And that can be challenging in multi-agent systems, but I think your fail fast is a good explanation for that. So you're not just compounding one error on top of another. I think that's really interesting. I do want to go to a few questions here, because I get asked questions similar to this a lot, which is about, okay, I understand everyone is using AI assistants right now, like Claude, Perplexity, ChatGPT. So a lot of people are familiar with AI assistants. We'll just label it that. But for those who are not programmers, not developers. Just walking us through the life cycle of an agentic workflow, because I think we have a question here from David Spurgis, I can think sums it up. Because I always talk about the machine learning life cycle, the data life cycle. So we do tend to think a little bit in life cycles. If you want to take a stab at that question, I can comment on it as well.
Sure.
Oh yeah, I keep forgetting we have a podcast recording on this as well. Either you can read out the question or I can for our listener audience.
Do you want me to read the question?
Yeah, your
Yeah, yeah.
interpretation of the question would be good because you're answering the question.
Can we think of AI agents like state machines? Yes. What I would say is that depending on the degree of autonomy that you provide your agent with, steps might or might not be known in advance. For example, for an agent with great autonomy of invoking the right tool at the right time, depending on its own brain, you don't know the steps in advance, right? You might invoke one action out of the 5 that you provided your agent with or not. And it depends on the agent itself. The kind of actions you mentioned in your comments, like collective information, distill, interpret, etc., are definitely might be part of plan of an agent. When it comes to the template or dashboard, there is no template, I would say, only a kind of canvas that you can have in mind when it comes to designing an AI agent. System message, large language model, knowledge, actions, and memory. Because at the end of the day, we might want to keep interacting with the AI agent, keeping a session memory of the conversation. Rather than templates, we do have orchestrators or frameworks that help you creating these agents. Now, these frameworks are typically pro code. And to mention a couple, we have LangChain, Llama Index, or Semantic Kernel. Those are libraries that can be imported in your code. They come with pre-built components that make the development of AI agents easier. At the same time, there are libraries that provide you with a low-code or no-code user interface to create AI agents, still following the same template of a system message, LLM, etc. An example is Langflow, based on LangChain, or AutoGen, which is pro-code library, yet provided with a graphical user interface that you can leverage if you don't want to code. As of today, especially if you're building complex multi-agent systems, AI developer experience might be of great aid. Eventually, you might want to design the backend in a proper way.
It is interesting because it's becoming a very confusing landscape. When Operator came out, I think it gives people a different view of agents because you see these demos of an agent being able to take over your machine, interact with dashboards, and do stuff like that. And I'm not sure, I've been out of the office a little bit this week, but I'm not sure if you've been following, is it Manus? It was from a Chinese startup, and they released some pretty impressive demos on X, formerly Twitter, showing long reasonings off for 20 or 30 minutes and come back. And we've other examples of that. There's a number of companies now have this kind of deep research. And these operators are quite interesting because they're showing advanced capabilities. The jury's still out in Manus. I haven't got access to it, and I'm not sure if you have yet, but it looks quite impressive.
I didn't have the chance to try it, but my thinking about that, and I don't know, maybe they will, but the thing is, they are amazing tools for productivity. What enterprises are looking for is how to land their own agentic state within their ecosystem of applications. Integrating agentic capabilities into existing enterprise architecture is probably the main topic of conversation that we are having, because the proliferation of tools, it's amazing. I agree with you, but how relevant are they in the context of enterprise applications?
Exactly. And speaking of enterprise applications, because you give some great examples there, I mentioned at the very start of this conversation reports from McKinsey, Capgemini, and other groups all looking to use agentic AI. How much of that is just experimentation versus implementation? We know we're very high in a hype cycle, but where do you think enterprises are in this?
I can bring the perspective of UAE, where I'm based, and which I think is a pretty advanced region from an AI perspective. Here we are beyond experimentation. Experimentation is a continuous cycle. So I'm not saying that the experimentation is over. What I'm saying is that we are already seeing like concrete projects in production of AI agents and multi-agents application, which is amazing because it means that the technology works and we are also able to capture real business value associated to that. And seeing that in real life rather than in a report, it's nice. I would say that this technology is landing nicely. What's really interesting to see is how to make it scalable at enterprise level. And the way that we are seeing it landing, in general, the definition of modularity in the AI agent context is that of seeing AI agents, skills, tools, and all the APIs that these AI agents are using as a repeatable asset. In application development jargon, it's containers, right?
Yes.
So eventually, all these agents will be nothing but APIs provided with a nice label of natural language description so that they can be reused across each others in groups chats, in sequential processes, so that eventually enterprises and startups and individuals might have this catalog of repeatable components that a planner can orchestrate. But repeatability is probably the key word when it comes to how do I scale, how do I operationalize a set of agents, how do I go beyond the POC stage.
Yes. No, I love that because you reminded me of something we started about 5 months ago, started to build out our own agentic workflow, doing something that a typical junior venture capitalist would do. A big part of that role is to look at all the research reports. So we built this agentic workflow. I'm not sure if you've got any use cases you'd like to share with us, but we're still in the process of building that out. But any other specific use cases you'd care to mention?
I can relate. Internal documentation is certainly a topic for AI agents. Personally, I'm biased because the cluster of use cases that I love the most are those that are meant to engage customers in new ways, consumer of mobile applications. This is the conversation I can relate to the most. Use cases where, as a user, you have this new UI, which might be conversational, might be not, that is hiding in the backend a group of agents, of product specialists, for example, working on your behalf, helping you finding the best product or just showing you things. That is amazing because it's also redefining in a way the UX itself, like having this dynamic UX that can accommodate different users, different profiles. This hyper personalization was not possible before because you can't physically develop 1,000 UIs depending on the number of users you are offering your application to. The way agents are redefining also the overall by design customer experience, I think it's a very interesting conversation. So this is the cluster of use cases I'm particularly happy to work with.
I want to highlight a question here from John V, but I'll just speak to it for a second to put it in perspective. With our limited use cases, I keep going between hallucination with guardrails is almost a solved problem. What is RAG is to prevent hallucinations, but we still struggle with hallucination. If I expand that out, my feeling is that a lot of other enterprises still struggle with hallucination for different reasons. One is that you can use RAG and guardrails, but there's only so much you can do there. As the models get better, hallucinations get more subtle, but I have seen examples where it's been quite blatant, especially when I'm doing those multi-agent systems. Of course, everyone's getting concerned about deep fakes getting worse. We see these very powerful voice agents that can emulate our voice. I'll read out John V's question because he wants us to address the emergent behaviors in Gen AI around alignment, such as faking. And John uses a pretty strong word here, lying. I still think they're prediction engines, so I would still say it's more prediction. But you can see with poor system prompting, like maybe I give it an alignment thing, and different models now have different types of alignment. You can pick models with no alignment. I think you gave a great example, Valentina. Imagine two agents talking to each other. What would come up with at the end of that? Yeah, so if you can talk to enterprises concerned around alignment, I think John is talking more people here. Because I had this podcast, we just released it today, it was with Ivan Lee. And sorry I'm going on here, but we had a podcast on reasoning models, right? And one of the things that Ivan noted, and I've noticed as well, these models are way too positive. They don't want to let you down. They don't want to fail. So you can see how agentic AI, they don't want to let you down. Did you complete the task? Yes, I did. And it's like working with anyone else. Did you complete the task? Yes, I did. But to what level and to what quality did you complete the task? So these agents are geared to please, to be helpful. And I can definitely envision when they're not being helpful, quite the opposite. That can lead to some interesting use cases that we're going to have to be very cognizant of. So if you can take your own stab at that, Valentina.
I really liked what you said, like LLM, generally speaking, to please people. They're people pleasers. I agree. That's why with AI agents, you have two additional elements that you can leverage. The first one is the system message. I can't stress enough how powerful is a well-written system message because it's focusing the scope of capabilities of the AI agents. And then you might have another agent, which is the critique, the pessimistic agent, the one that is gonna review and boycott the output of the previous agent to make sure that it's actually good. but also to address the concern in sense of hallucination, which is, I don't want to minimize the answer just saying, just initialize a critic agent, right? When you develop an AI application, and we talk about AI agents, at the end of the day, AI agents are AI applications. You have to think about different layers of security and guardrailing that you might want to enforce. Think about that as an onion. At the center of the onion, you have the large language model, and you can do very little about that because the LLM has been trained already, meaning that if it is biased, it is what it is. Your power here is to pick the right LLM. And there are system cards associated with LLMs. You can understand which is the right one to your use case. And then you have the second layer, which is prompt engineering. So whatever you can actually write in the system message that is going to adjust and tailor and maybe counter bias the behavior of the LLM. And then you have grounding and guardrailing. So grounding is basically grounding the model to your knowledge base, so it's iterative augmented generation. And guardrailing is something that you might want to enforce either at the system message level or with external APIs like content safety. Content safety is an API which will filter like input that are falling into potentially harmful categories, and other tools that can prevent prompt injections. All of this is part of the application logic to build around the LLM. And then there is the user interface. We don't have to forget that not all AI applications needs to be conversational. So you might want to limit the flexibility of the input that users can provide, which is a way of limiting the risk of hallucination. That might be, for example, by providing starter questions or a form rather than a chat. These considerations that are part of the design of the AI application are methods to limit the risk of the model to hallucinate and eventually the AI agent to perform things that you don't want to perform. And last but not least, you mentioned imagine an AI agent invoking tools autonomously. Remember that you can always provide a validation station in between. You can develop your AI agent in such a way that the AI agent, before invoking a tool, will always ask for permission and will not go ahead without. Of course, it will require extra click from your side, but it means that you are reducing the risk of invoking the wrong tool, for example. So all these considerations are part of the AI application design, I would say.
Yeah, I really love that answer, Valentina, because you went through a laundry list of best practices. Grounding, I find, is so important. And that's excellent advice. You mentioned lots of different terms for this, but LLM as a judge, or I prefer to say LLM as a critic, right? Because we started doing that. We were familiar with LLM as a judge, but we started doing what some people are calling AI supervision or AI alignment via AI evaluation, right? So, John, if you're worried about this, assume that the LLMs are going to do this to a certain extent. You have another LLM, can be the same model or a different model with good grounding to making sure you're using one AI to evaluate the outputs of another one. So I think very sound advice. And I do want to beat my own drum here, Valentina, if you don't mind for a second, because I remember when I was doing the introduction slides, I'm going to do a talk next week in prompt engineering because it just amazes me that I talk to a lot of developers, a lot of people in business. And I think the problem with the AI assistants, they're so good. It can be Claude 3.7 Sonnet, it can be ChatGPT. The assistants are very good at working with what I call weak prompts, right? So I can say something like a well-known example is that people ask you, I need an exercise routine. Okay, that's a weak prompt. And it will give it to you, right? That's a weak prompt. And I give it a strong prompt. I'm just starting out going to the gym for the first time. I want a low impact regime because I want to sleep better than I was strong prompt. I feel like I struggle to convince people that being better at prompt engineering, prompt design is so important. And then bringing your domain expertise to that prompt design. Because when we talk about grounding, how are you building the system prompts around that? I think people get very caught up in how these agentic AI workflows work, the sophistication of them, but forgetting the level of skills that they can currently bring to the table with good prompt design, some prompt engineering, and certainly bringing their domain expertise. Usually there's some kind of domain alignment. I'm not sure if that's a perception I have and maybe some misconception, but do you find across business or development teams that a lot more stress needs to be put on prompt design as well as getting those domain expertise into the agentic workflows?
Yes, 100%. I think that we need to differentiate between two different kind of prompts, the system message and the user prompt. Prompt engineering is beneficial for both, but user prompt is the end user natural language question. That's me, you will ask ChatGPT or I don't know, Manu's application. And it's important that we structure the question in the right way. But the system message is the backend set of instructions that we provide our application or AI agent. There, prompt engineering is crucial because we are shaping what our AI agent is meant to do. Again, think about that as the job description of the agent that you want to hire. So the job description needs to be detailed, need to list the things that we are expecting our AI agent to be able to accomplish, needs to mention the tools that this AI agent will be able to leverage, the knowledge base that it should be grounded on, and so on. Having the skill set needed to write this set of natural language instructions in the right way with the right formatting, because format matters, right? The order matters. There is this recency bias, which demonstrates that if you repeat the most important line of the instructions at the end of the system message, it will weight more than if you do that at the beginning, because apparently models remember like the last line better. So you might end up with very different results just by changing the order of the list of instructions that you are providing the AI agent with. Super important prompt engineering, especially for AI developers, for users as well, but AI developers is a must.
That's my hot take. The must-have skill for 2025 is prompt engineering because the tools are getting so powerful and so user-friendly that they just need good instructions. My hardest question for today is, and I know I've asked you a couple of hard questions, Valentina, so I appreciate you being such a good sport and allowing me to pepper you with these questions, but so much has happened in the last couple of weeks and months, right? These reasoning models are coming out ever since OpenAI's O1, and then we had DeepSeek R1, and of course, Operator, and lots of other models coming out as well. But looking ahead, what are the opportunities or developments that you anticipate AI agents will unlock in the months ahead?
What I see, it might be conservative, so I don't know. It's just what I feel, is that it's getting more and more important to define the ecosystem where these agents are going to collaborate. Because the power of one single AI agent or a group of AI agents has been proved. So it means that we know that these things can be done by AI agents. So what we need now is a robust framework where these agents can live. Because again, we mentioned the proliferation of tools to do things, right? LangChain, LangGraph, operators. We have plenty of these tools. But how do I qualify a proper landing zone in my large enterprise to let these agents live and being consumed in a smart way? So this is probably the main conversation that I'm expecting in the upcoming months. And yes, it will be up to architects and AI developers to solve the dilemma. But this is my view. And of course, I'm expecting cooler applications to pop up, like siloed and applications rather than platform. So I think that the shift here is how do we enable the platform for us as enterprise to build, deploy, and manage the life cycle of AI agents.
Yeah, that's such an important point. There's so many tools to learn out there. So what do we focus on? What is the industry going to focus on? Do you remember Onyx, which was the open source formats and was used to facilitate interoperability amongst various machine learning and deep learning frameworks, right?
Oh, yes.
So
The open
10 years
source
ago,
form, like
exactly.
templatizing and standardizing models. I remember.
Standardized
got
models
both.
work to a certain degree because you had so many machine
Yeah.
learning and deep learning frameworks. How do we standardize them? And I think you're right because there's so many frameworks out there.
If you don't have a tool, the moment you eventually decide that your skills and your agents will be APIs, because an API is agnostic, right? So you might want to develop one agent in LangChain, the other one in semantic kernel. I'm not saying that it's a best practice, but the way AI agents are built and consumed allows this flexibility of tools as well. Of course, I think one framework might be easier, but I don't see it as a hard requirement.
I had this debate with a developer and I basically said, well, a couple of years or even sooner, the agents will be so good, it can just recode it all to the latest framework to do the switching automatically, refactoring, as we say.
Yeah.
So we'll see.
True.
But one other thing I want to bring up, Valentina, is you are speaking at ODSC East. You're going to be hosting a virtual workshop. So everyone listening can actually join in as well if they choose to. Can you talk a little bit about it? Because I believe your virtual workshops is going to be on multi-agent systems.
Yes, we will talk about multi-agents workflows. So different way of designing the way these agents can collaborate. And we will probably rely on one orchestrator. I think I mentioned LangGraph in the abstract, but I will keep it flexible because we are evolving. So we will see what the market will have to offer. But
Yeah.
again, the way I want to depict this new agentic state we are trying to build in our organizations is that of modularity and abstraction. So that approach of containerizing skills, tools, and agents as repeatable assets that we can consume, regardless of the code or framework we use to adapt them. Of course, if you're using LangGraph, it's automatic to orchestrate these components through LangGraph, but it's not the only option. We will see how we will shape this conversation. But yes, this is the idea. We will talk mainly about multi-agency, and we will see some nice demo and code.
Excellent. Yeah, because I'm sure when people are listening to this podcast or on this live stream, our questions have resulted in yet more questions for you. I haven't seen a number of Valentina's talks and workshops. She is one of the best in the business of explaining this stuff.
I'm glad.
No, seriously, check out some of this work online. She does an excellent job of explaining these quite sophisticated workflows. And speaking of which, Valentina, any other ways to follow you? Because you mentioned LinkedIn. You publish a number of books. If you can talk a little bit about how you're educating people in this space and how to follow you.
Sure. I love to act like the influencer that I am not. You can follow me on LinkedIn, which is the only social media that I use, and Medium as well, where you can find many interesting publications in data science, AI, etc. So I have a Notion website where you can find all my articles for free. But I will share also the personal page that I have, so you can see all my articles there. I do have a GitHub account as well, where I publish repositories from articles or from sessions with ODS SC or other organizations. And I also wrote 2 books with Pact Publishing that you can find either on Amazon or directly on the Pact website.
Yeah, check out the books. I'll also include it in our show notes for our listeners. Sure. Valentina, this has been so insightful. Loved your explanation, your deep dives into the agentic AI frameworks. And I definitely feel like I'm coming away with a better understanding and maybe a few little tips on how to implement this better. So thank you so much. And as always, we're going to be looking forward to your virtual session at ODSC East.
And thanks a lot for having me here. See you in Boston virtually.
No, our pleasure, Valentina. Thank you so much for taking the time. Bye for now.
Bye. Bye for now.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. Today's episode is sponsored by ODSC East, the leading AI and data science training conference this May 13th to 15th in Boston and virtually. Learn more about the event at odsc.com/Boston, and don't forget to use the code ODSC Podcast for an additional 10% off. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.